production rate, production rate, production rate. Stamping and thermoplastic is a really good solution, efficient solution for ribs. We don't consolidate the preform. We go directly from the AFP machine to the stamping press. Thanks to direct stamping, then you save some step in the process, so you save money and you save time. With the infrared, you heat the two surfaces, you close the press, and then you got a welding.
Did you put anything between the surfaces?
Nothing. Future single air is 80 aircraft per month, so you have to remove all the steps that you can remove. A few minutes for stamping, a few minutes for welding also. Everything is driven by the rate. We started working on wings, composite wings, years ago. Quite quickly we identified that stamping and thermoplastic is a really good solution, efficient solution for ribs. So we started with a smaller ribs in the past. Then thanks to that we were onboarded on the Wing of Tomorrow program with Airbus, where we designed our first big ribs, high-loaded ribs, quite thick, etc. We knew that we could improve the results of what we did in Wing of Tomorrow. Alone, we decided to say, okay, let's start again working on ribs.
Yeah.
So we redefined specification, generic specification for a wing rib that could fly on a single air. And then first we redesigned the aluminum version. So we made the stress, we made the quotation, so we created a reference, weight, cost in aluminum, forged and machined. And then we say, okay, now we've got our reference, let's do it in composites. The two parts laid with the AFP machine, flat. We don't consolidate the preform. We go directly from the AFP machine to the stamping press.
Interesting. So to be able to do that using AFP directly to press.
Yeah.
I think I know what material you're using.
That's the LMP AK resin from Victrex.
Yes, okay.
That works very well. So we call it direct stamping. Around that there is approximately 10 dire patents that make it working.
Yeah.
So it's quite tricky. Easy to do good parts, but difficult to have the right level of mechanical behavior.
Absolutely.
And so we change everything in the process to reach the target. And we patented all of these small details that are really key to succeed. So we use the AFP because we can then optimize the number of plies in the parts. If you have a look on the back of the part.
So this is not a consistent thickness?
No. You will see on the back the ply drops in all the directions that can be optimized thanks to the AFP machine.
Okay.
And thanks to the AFP, you can also improve your buy-to-fly ratio.
Yes.
Deposing only
you reduce your weight
necessary for the part.
That makes sense.
So you limit the waste as much as possible. So that's the main reason. And then as you lay flat, you can be full speed.
Yeah.
And then you use the press only to go to the 3D shape. We worked on the stamping process with the simulation with Aniform. We developed together new modules in their software to address our challenges, which are nobody did that previously. So thick laminate stamped with all these ply drops, etc.
Check out who I've got with me right now. Gentlemen, what an absolute pleasure to be able to be, with all the contributors. And check this out, you got the award.
So we are very happy to work together with the hair on this part. It's a nice demonstrator to show what they are capable of and what we are capable of. And together we can make these beautiful things.
So thanks to direct stamping, then you save some step in the process, so you save money and you save time.
And the fact that there is no autoclave on this, you just stamp directly is very impressive.
And because all the project has a backbone, which is production rate, production rate, production rate.
Yeah.
Future single air is 80 aircraft per month, so you have to remove all the steps that you can remove in the process to succeed. Thermoplastic have the advantage to finally be transformed very quickly, a few minutes for stamping, a few minutes for welding also. So everything is driven by the rate.
Yeah.
For example, we've got more than 1,000 part number on the A350 clips.
Okay.
and we only manufacture that at a rate of actually 8 to 13 aircraft per month with 2 machines. Because every 6 minutes you've got a clip coming out.
Yeah.
So it's very, very adapted to high rates. We can talk a little bit about welding if you want. So
Yes, please.
we
Very
did
curious.
also we use technology from the LIST, another partner of this project. So LIST is a Luxembourg technical center, research center, and they have this technology about infrared welding.
Okay.
So why we choose this technology is that because the laminates are quite thick. So you try to use a technology where you heat directly the surface, the two surfaces that will be in contact.
Yeah.
If you have 10 millimeters of laminates and you try to push the energy through the thickness of the laminate,
Yeah.
and it's a mess.
It's too long. Yeah.
Yeah, so go directly, and with the infrared, you heat the two surfaces, you close the press, and then you've got a welding. You just have to manage, the cooling, etc.
Did you put anything between the surfaces?
Nothing. We have another step that is just behind me, where we say, okay, we could also, when you manufacture such a part, you've got some waste when you trim, etc. Let's collect this waste and re-inject overmold functions on the part.
Mm-hmm.
It can be small clips for systems,
Yes.
or some local stiffeners, things like that, to go to a zero waste solution.
So you're taking a material which is a primary A structure,
Yeah.
and after you recycle it, given the grade and the quality, you can still use it in aerospace.
Yeah.
It's just kind of like different applications.
Exactly. So you can add function on the same part, or you can manufacture small parts for the same program. Then you just follow the rate, production rate, then you will have no problem.
Thank you very much
Martin.
for your time and for sharing. I am
welcome.
really looking forward to seeing your site at Nantes tomorrow.